guests, esteemed academics, and ladies and gentlemen. It's with great pleasure that we welcome you to the 41st installment of the inaugural lecture series proudly organized by the Faculty of Graduate Studies of the University of Moratuwa. To formally begin today's commencements, I'd now like to invite Dr. Tilini Piyatilaka from the University of Moratuwa to introduce our professor for the day, who will be Professor Thushari Silva from the Department of Computational Mathematics of the Faculty of Information Technology at the University of Moratuwa.
Good afternoon, Vice Chancellor, Deputy Vice Chancellor, Deans of Faculties, Heads of Departments, Directors, distinguished guests, and ladies and gentlemen. It is my great pleasure to welcome you all to the inaugural lecture of Intelligence with Integrity, the Rise of Responsible AI. In an era where artificial intelligence is rapidly transforming every aspect of our lives, from science and industry to education and governance, it is essential to reflect not only what AI can achieve, but also on how it should be developed and applied responsibly. Today's lecture by Professor Thushari Silva will explore the critical balance between innovation and ethical responsibility, highlighting the importance of transparency, fairness, accountability, and trust in AI systems. As we stand at the forefront of this technological revolution, the concept of responsible AI is no longer optional, it is imperative. We are honored to have Professor Thushari Silva share insight on this timely and significant topic. Professor Thushari Silva is a professor in artificial intelligence, distinguished academic and researcher in artificial intelligence with over 18 years of teaching and research experience at the BSc, MSc, and PhD levels. Currently serving as a professor at the Department of Computational Mathematics, Faculty of Information Technology, University of Moratuwa. Professor Silva has made significant contributions to the field of artificial intelligence, explainable AI, machine learning, semantic web, big data analytics, and ontological modeling. She holds a PhD in information systems from the City University of Hong Kong, where her research focused on expert recommendations in research social networks, earning a nomination for the Outstanding PhD Thesis Award. Her academic credentials are further supported by an MSc in Information Communication Technologies from Asian Institute of Technology, Thailand, and a first-class honor BSc in Computer Science and Statistics from the University of California. Professor Silva's profile research career includes over 40 journals and conference publications in esteemed venues, addressing cutting-edge topics such as personalized recommendations, big data analytics, and AI-driven systems. Her academic leadership is evident through her role as the head of the Department of Computational Mathematics, President of the Sri Lanka Association for Artificial Intelligence, and Director of LK Domain Registry. She is a committed educator, adept at curricular development for undergraduate and postgraduate programs, and has received numerous awards, including the Outstanding Research Performance Award of Excellence from the University of Moratuwa. Professor Silva's impact extends beyond academia, contributing to national AI strategy formulation and fostering innovation in AI through collaborative and multidisciplinary research initiatives as a committee member at the National AI Policy Development Committee. Professor Thushari Silva, over to you for the presentation, madam. Thank you.
Thank you very much. Very nice introductions by Dr. Silene, head of the department. And good afternoon, everyone. And I would like to warmly welcome you all physically who are present here today, as well as who are connecting with me via online to this inaugural lecture conducted by Faculty of Graduate Studies, University of Moratuwa. Vice Chancellor, University of Moratuwa, Deputy Vice Chancellor, University of Moratuwa, Deans of the faculties, heads of the departments, senior professors, academic staff members, respective colleagues, staff members, invited guests, my dear students. So today, I'm going to talk about the intelligence with integrity, the rise of responsible AI. So let me ask a question first. Before I run through the agenda, I will tell you in artificial intelligence and why do we need to go for responsible AI and the framework that has been proposed for responsible AI and principles governing and responsible AI and research aspects so that we do need to work on towards this responsible innovation. So then my question is, so I assume that you have parked at color light. So while you were driving, you were stopped. And the lights were red. So you had to stop, you stopped. And at the same time, you noticed that none of the vehicles are passing through the other roads. So you have the freedom to go and break the rule. So even the light is red, you need to go. You can go, but there are rules. In terms of integrity, so you shouldn't cross the road. Even though all possible ways are visible, you shouldn't do that just to save other things. Or maybe it's the most needed thing at that moment, but shouldn't do that. So that's the integrity. So let's see how it could be applicable to our context in artificial intelligence. So artificial intelligence is the scientific and technological discipline focused on simulating human cognitive functions, reasoning, learning, and moral judgment in machines. So this is the value here today. So the innovation happened until today. So most of the innovation happened before the artificial intelligence, like internet, steam engine, electricity. So they all had the power in the machine, but the control was with the human. Then why AI is different? AI has the power and AI has the control. So when it comes to the integration, a combination of both innovation in one thing, so it's more powerful because you lost the control. Control is no longer with humans. So that is why the AI is really taking attention from everyone. So now these intelligent systems, which are no longer optionals, but they have become the infrastructure. They have become the infrastructure of every innovation, every device, every mechanic. So whatever the smartphone you are holding right now, maybe you are looking at it while listening to my lecture. So it has all parts of innovations, internet, and ability to see the world through these few windows. And it captures you, who you are. It records your actions. It monitors you and give you some intelligence guidance. So that's intelligent system. So that's mainly available in our hands, easily accessible. So is it powerful? Innovations without the responsibility will be leading to a risk. So what artificial intelligence? Maybe it's a great addition to the humanity ever known. So people will be surprised to see that the power of AI or the systems that uses artificial intelligence techniques, methods. So they have come far and they could now identify very accurately the failures in hearts. Not only that, they could analyze most of the scan reports very accurately, sometimes better than experts, doctors, medical experts. So on the other hand, we will have very nice tools, list of tools, mind-blowing AI tools. We could take videos and make a movie in very short time. And you can become a director, movie director in 5-10 minutes, just passing the prompt. And chatbot, you could ask anything and do many more. So it's a kind of knowledge base, which is similar to human. So even you can ask from Einstein. And writing is perfect. You have wonderful tools available for designing and writing. And other evidences are coming from the Boston Dynamics, the robots. So they are making robots which are things, behaving similar to humans. Will it create a risk? Is it a great risk for humanity ever known? Let me ask another question. Assume that autonomous vehicle is making a kind of accident and killed a passenger or pedestrian. Who should be charged? So similar incident happened in recent past. The self-driving Uber kills Arizona woman in first fatal crash involving pedestrians. So that's a kind of point that we do need to really look at it, the innovation. So we cannot punish the people who develop the innovation. So, but we cannot let them go free. And another news, Reuters reported that US appeals court rejects copyrights for AI-generated art lacking human creator. So artists have claimed that their names were used without getting any consent. Their songs were rewritten without getting their consent. So lots of issues, ethical problems. So I'll ask one more question. So can you identify or can you tell which person is real from those three pictures on the left, right side? My right side, maybe yours. Which one is real? Which one is fake? Can you identify that? First one or second one or third one? But it's quite hard to guess. That's why I think I don't get any answers. So those are AI-generated ones. Probably the last one is real. The other two were generated by this AI technique. It's very powerful. Even we can't recognize who they are, who has been generated wrong. So that's the power of this technology, the power of this innovation. Technology has been challenging human performance. Not recently, from the past. So at least there are two popular events created the revolutions in history of artificial intelligence. So one is in 1997, the IBM supercomputer, the Deep Blue, won and beat the chess world champion Garry Kasparov. So there were around 200 million options that could be analyzed by these machines in a second. So very powerful way. It predicts, calculates very fast. This is not just a chess match. It's not just a machine won a chess match. It's a signal sent to us, sent to humans, saying that machines can work better. It could strategically think and plan and bypass human. For another innovation in 2016, Google DeepMind AlphaGo. AlphaGo is a game which is quite complicated, very complex than the chess. So it was a game played with the world champion Lee Sedol. And the Google's DeepMind AlphaGo beat the world champion. So that is complicated game. It is not like the earlier one, IBM Deep Blue used this brute force algorithm and some heuristics to find out the possible strategies to win the game, but it's not like that. 2016 one, it's really complicated. And it needs to learn the pattern. So that's where the pattern learning is possible, and the neural networks kind of at the beginning of this technological era, the neural networks were formed to recognize those patterns. So these were kind of signals sending to us in the past. So these unlimited boundaries of the artificial intelligence applications, so really bringing the humans and supersede their powers. So this has been again proven. According to the statistics, the machines are now capable and better than recognizing or reading books, writing letters. So that first human cannot write. Reading books, comprehension, understanding the language. So they are very powerful. Even generations of the programs, making a program, say are humans in the industries, they had to spend few months, weeks, but few hours, few seconds, few minutes are sufficient for these machines to generate these wonderful systems. Reading comprehension, image recognition, so better than all of us. So all the time, the performances wise, the machines have excelled. So they surpass human again. So where we are heading. Great power with a great responsibility. So all the benefits AI offered carries certain risk. So those were generated through the algorithmic bias, the privacy losses, and also the misuse of the autonomous weapons. So now we are experiencing in this war what's going to be happening. So that really demands us the responsible governance are critical. So we need to be responsible now better than ever. So do we still remember the good old times of artificial intelligence? So earlier they had explicit rules and based on the knowledge, domain knowledge. So those rules were defined. So they had very focused purpose, direct programming. So intelligence tool like expert systems are very good at modeling a solution for a given domain. So define explicit rules. And very easy to understand why these answers came. And explaining those ideas were pretty much straightforward. So now what we have done, we have changed the paradigm. Earlier, they were given kind of specific rules. Now we were feeding them with data, asking them to, hey, this is my data. You go and learn and tell me what is the solution for this. So do everything based on data. That's the data-driven intelligence. And that is very common in machine learning, deep learning, and other areas like what we are experiencing today, language models, large language models. So they are carrying lots of these data-driven AI approaches. So you are given data, you are showing lots of data, and then asking machine to learn from the data. And yes, so they generated something like your output is in this number. So what does it mean? So the user cannot understand what is meant by this row value is 0.93, P is 0.93, what is it? So why did you do that? Why not something else? Why this is number? So why it can't be classified as not a cat, but can't it be bat or rat? When can I trust you? When do they foil? So what's happening? So we don't know, but we use it. But tomorrow, the next step, so we do need to add more the knowledge into these machines. So not just learning from the data, and we are making decisions based on our knowledge, but not only with the facts or data that we have seen. So that's how human work. If the machines are going to be like humans, so then can't they use knowledge by using only data? So if you use these explanation or the knowledge and give, why did I recognize this particular object as a cat? It can say that, yes, it has fur, whiskers, and claws. So this is none other than a cat. So that level of explaining is required, or knowledge base needs to be improved and added to this data-driven intelligence. Why do we need responsible AI, basically? So what we are capable of? Many people, many users, everyone is using artificial intelligence. It's very common in the society today. So whoever expertise is modified with AI. So where the AI risk and challenges generated from? So they are very good at collecting data and downloading from the public sources. They call it trained data. I got that data. And very nicely, they show that here I got 100% accuracy here. So my model is perfect. So what went wrong? So they collected data which are not suitable for the context fully. So demonstrate certain facts, but not enough, maybe. So they have collected the data related to one female group, but ignored all male groups' behavior. So that is a data bias. And you amplify this bias because you put that into a model and got output. So the model either amplified the bias or remained the same, or left the same bias in the model itself. So either way, so you're adding bias interpretation to the data. Even though you take pre-trained models, so many students, many researchers are very good at borrowing somebody else's work and using it as their own and generating results, saying I did something good. But So that models itself are pre-trained to a different context. Have you ever observed that why the country like Sri Lanka still are not having much of the face recognition systems? So that's a very famous and a very popular application everywhere. So, but it is not implemented because the accuracy is a problem. So those models are pretty much trained with the US people, and their pictures are different from Asians. Asian faces are a little bit different. So there's a big gap. And the model trained to rectify the US person's image will not be able to use directly as it is for our case. So the accuracy wise, there's a big compromise. And the data bias and the model bias and the algorithms that we are going to choose, the parameters that we are going to choose, so are all full of bias. And deploy model amplified the bias or carried the same bias, and then it will not be performant as usual. So that is one of the risks that we are having today. Maybe other times, so these artificial intelligence algorithms, techniques are providing us multiple ways to overcome bias, but kills the certain features. For an example, we have undersampling techniques. We manage to reduce the number of samples in order to have a fair model. So that way we compromise the features and the relatedness. So that brings another problem. In case of oversampling, we are just adding more data to the sample which do not have enough data. So by doing that, we are again adding more bias. So either way, we try to do something, but the outcome is kind of bias. So AI was shifting to data-driven modeling, and all solutions were based on data-driven AI models. So like deep learning and large language model, transformers. So all the models that you see and heard are data-driven. So initially we had weak AI models which are very specific to a problem, and they used strong statistical experimental designs. So they do need to design and make sure that the particular data set is used. So they need to pre-process data, fine-tune data, and they need to make sure that data is displaying this particular distribution. So they modify the data, right, to meet certain assumptions. So these models are based on assumptions too. We need data to be followed normal distribution. So the noise should be normally distributed, and then we put them into the model. So they were like driven for particular purposes. So not very generalizable. So only for that particular problem. And by doing that, no need to have a way to do proper validations in the real time. Their behavior is totally different. So no evidences were collected, no proper validations. So then, but they claim to be strong. So they see that here having 100% accuracy. So this should be same work as human work. So that's another thing that we do need to think about, like one data set that you download and no errors, error-free real-time data is not to be seen anywhere in the data set, but you're claiming your model is perfect. There's a misinterpretation and misunderstanding of two concepts. The first one is artificial narrow intelligence and artificial general intelligence. So the artificial narrow intelligence focuses on one particular case and uses very simple models. And when it comes to the artificial general intelligence, we try to generalize to any case. And the model could perform in all cases with the same performance. So that's a kind of another misunderstanding that we do need to responsibly handle. when AI is not responsible, we will be having certain problems. So there are privacy violation. And we do have this black box model. You put a prompt and then you got an answer from GPT kind of models, data-driven models. You have no idea how this answer came. And you believe that because it's given by this GPT, everybody uses, so then that must be correct. Or maybe that's the thing. But you forgot that. At the end, below it says that use this information. GPT itself says, okay, so this information may not be correct. And use it after reviewing. You need to review it before using it. And we are too busy to read that small part, but we read only the output generated by GPT and take it as correct and use it. So when these not responsibly innovated, and then we do have a problem. So what is this responsible AI? The responsible AI framework introduced by the University of Hull, it carries basically 3 different characteristics. So here I'm not talking about this European Union Act, and they are describing responsible generative AI framework. So mine is quite different. Here I'm following this responsible AI framework for general responsible AI. So one component in that framework is explainability, explainable, making AI understandable. The other one is making AI fair and equitable. The third dimension describes it should be trustworthy. So we should trust what it generates, making AI safe. What's being fair? Equity, equality, or justice? We assume that none of the people should be treated unfair, so they should receive everything equally. Everyone benefit from the same support is the assumption we are holding under equality. Okay, so equal treatment. So our students in our classrooms, we equally treat them. Equity says that, so equal treatments may not be sufficient, so you have to give the support they need. Everyone get the support they need. And the barriers, in this picture, the barriers to watch the match was somehow handled. So one person was received extra support. And what is justice? So there, the barrier was removed. Everybody has their own levels to do the same thing, but there will be no barriers. So how do we go for the artificial intelligence and remove these barriers and generate cues? Okay, before that, I will talk about the explainability a bit. Explain it like a human, that's what we are expecting, right? So everyone who are using these systems are ready to read the message or the output as general human beings. So if the technical things come, so we are not happy about it. So what is this interpretability? Explainability has a great feature, that is interpretability. We should be able to interpret the result, or we should be able to understand the cause of a decision. Why did we make that decision? In other contexts, can be a degree to which a human can consistently predict the model results. So consistence, no matter where you apply the model should generate the consistent results. So now we have several factors. So when we apply to certain countries, certain languages, even our great powerful language models are not capable. So interpreting the results as it is quite handled, but not in the convincing manner. The higher the degree of interpretability of the model, the higher the likelihood of a user comprehending its prediction. So generally, when it comes to the human, because machines are supposed to behave like human. So that's what the original thought about intelligence. And we have mental model for our environment. And when it is updated, when something happens to you, you're updating your mental model related to any question. And this update is performed by finding the explanation for the unexpected event. So we can justify, okay, you might see that, okay, so because of this that happened to me. And then I can, in the future, understand the reasons and update my models accordingly. So interpretability should be a kind of component we should add to our innovation. So if I dig a bit in those explainability, so we have multiple techniques, pre-model, in-model, and post-models. So the pre-model is that we are modeling the methods, and these methods are depending on the data. And before we apply or we use data, we do the exploratory analysis and say, can we generate high confidence for this outcome with posterior distributions? And when it comes to the post model, it's quite different. So we do have techniques. Okay. So for an example, let's say that you're generating a system which identify who the animals are. Let's say you inserted a picture of a zebra. You know that zebra is unique because of the stripes on his body. So that should be a kind of a very sensitive way to predict zebras in presence of horses and other similar animals. The post-model technique should be able to interpret the model predictions and give you kind of very convincing output explaining why this object has been classified as zebra. And when it comes to the in-model technique, here, actually, the post-model methods could generate misleading explanations. So the students or researchers who are in this explainable AI, they know that the well-known Lyman, Sharp, and breadcrumb techniques. So we could use them to fool the machines, fool their algorithms, and generate the bias classifier. So that's a kind of the reverse thing I'm telling, but normally we try to use these techniques, Lyman, Sharp, okay, to explain why this model behaved this way, and that's the justification. But now we have a way to use these Lyman, Sharp and fool the models and generate the output as what we want. So this explainability, post-model method, so could generate misleading explanation. And then our solutions should be coming with this knowledge bases, knowledge graphs. So when it comes to the very sensitive domain like healthcare, So the domain like healthcare definitely needs certain regulations, and they were trustworthy and need to be responsible, right, when the innovations happens in those healthcare sector. So LLMs used or any deep learning models they use, they need to be nicely balanced with this multimodality and the predictive power and the complexity, and at the same time, interpretability, fairness, and the trust. The fairness and the trust, because that should be common to everyone. All patients should be treated equally. And their individual characteristics nicely be modeled. So not only the ones who are presented in the test, but also the future candidates, future patients should also be recognized with similar accuracy. So interpretability, understanding, right? So that needs to be improved, not only with the data and the techniques that we're supposed to learn these intermediate model outcomes, but so they can further be improved by knowledge graphs. So the knowledge graphs or the ontologies governing the context knowledge would increase the focus on explainable AI and LLMs. So that facilitate the advanced reasoning capacity. So why did this happen with rules? So that's the real integrations of expert systems like doctors' knowledge with these data-driven techniques. So in terms of the other factor, that's trustworthy artificial intelligence, trustworthy solutions. So according to these pillars, there are 7 pillars here. And these 7 pillars defines different aspects that you do need to cultivate in those AI innovations in order to become trustworthy. So human in the loop. So more and more integration of humans to the innovation and testing and validating with the support of humans, support of experts, it's really needed. And technically, they need to be robust and privacy, transparency. So whether we can tell why these answers are coming out. So it should be catered for all the communities, everyone equally, and societal and environmental well-being, and need to be accountable. So I'll describe some of these factors in upcoming slides. So then human in the loop. So we have to get the first requirement to develop the trustworthy AI. And those concepts, so if you have learned about how these LLMs like large language models, agentic architecture, so how do they work? So they do have this pre-trained LLMs and fine-tune with human written outputs and generate the supervised fine-tuning models. So when we add a knowledge graph to these human written outputs, so then now we will train these LLMs or large language models or transformer models or small language models and even agentic AI frameworks with these knowledge components, the knowledge. And these knowledge graphs will give the reasoning, advanced reasoning capabilities. So the trained models are having high interpretability, so accountability. And at the same time, the next training process, so then humans were asked to run the output again. So human again involved in the second phase, step 2. And again, we fine-tune models. And finally, so we will be able to generate these outputs, the last training process, and using reinforcement learning from human feedback approach. So we will be able to generate a predicted reward, predicted output, which is part of the trustworthy AI solution. So these knowledge graphs further can be applied to any context, and not only for healthcare. So information retrieval, extracting these concepts and their relationships, the graphical mode, and can also be further added to these techniques, machine learning, but it has been now enhanced with these semantically similar or related pieces of information. So that's the knowledge that we feed into these models, and it could improve the context as well as these answer generations of the systems. So very focused, very much accountable and trustworthy. Accountability counts. Who will take the responsibility of the output? So my question again, which I asked at the beginning, who will be responsible when autonomous vehicle hits a passenger, pedestrians, and killed him? People should be accountable for AI systems, not the person who innovated, but they need to innovate in a way that it could capture all possible movements which were not happened before, not only from the data, but also observing the things very correctly. So we should use not just one matrix for training and monitoring, but we choose multiple matrices and make sure that they are appropriate, they are related, and they are not for the sake of like applying, but they really need to reflect what exactly the outputs are. So are there any limitations? And then we do need to continuously monitor. So not just like traditional software engineering approach where we developed and then we launched and no need to monitor, but we have to monitor these AI solutions and come back and retrain, redesign, redevelop, and then again place in the real place. So in terms of privacy, we are going to make sure that the data that we have used are protected. And even if you have used sensitive data, you have anonymized and aggregate the data in such a way that it cannot be directly refer back and identify what exact data point is. For an example, let's say if you have used the patient's data, right? And some of the patients who are suffering from those diseases, those are very private. And those data can be used to train a model. And the model can be traced back and identify who the individuals having those sicknesses. So in that way, you could say that the privacy will be violated. And we better to use our models using federated learning. So we should protect the privacy. We should give the edge device to carry the training part, keep the data which is related to you at your place. No need to share it with the global models. And the result only can be coordinated. The training can be diversified and federated. So that's the way that we could protect the privacy of the data. So in concluding my talk, so what I have presented to you all, so we need to innovate with integrity. The future of AI is not defined by how powerful it becomes, but how responsibly it is guided. So it's time, and innovation now have been moving from the pure data-driven application to the knowledge plus data-driven innovation. So we have to embed the knowledge, the domain knowledge into those models, and rather blindly asking to model to learn the pattern, give the real answer. So it's quite not successful. Pure innovations lies not only in algorithm, but in the values, what we embed in them. Not just intelligent systems, but the systems worthy of trust. And thank you for listening for this lecture. And plus, I would like to dedicate this lecture to all my mentors and everyone who supported me. And thank you very much for the opportunity given to me from the FGS. Thank you. Have a good day.
Thank you very much. Our heartfelt gratitude to Professor Thushari Silva for that insightful and compelling lecture on responsible AI. Your expertise and perspective have undoubtedly broadened our understanding on the topic. As a token of appreciation to Professor Thushari Silva and her contribution to this inaugural lecture series, I now invite Professor Kanchana Pereira, Senior Professor, Faculty of Architecture, University of Moratuwa, to present the lecture memento to our distinguished professor for the day. Additionally, I'd also like to invite Professor Thushari Silva to please accept the lecture memento. Thank you, Professor Kanchana Pereira and Professor Thushari Silva. Before we conclude, I'd like to take a moment to acknowledge and extend our appreciation to the esteemed sponsors of this inaugural lecture. Cargill's, our event sponsor, Daily FT, our print media sponsor, and the Sri Lankan Scientist, our social media sponsor. Thank you to all of you in the audience for being such an engaged and thoughtful group. With that, we officially bring today's 41st inaugural lecture to a close. Thank you all for being a part of this enlightening gathering. We look forward to welcoming you to the next iteration of this esteemed lecture series. Have a wonderful day ahead. Thank you.